This lesson is going to take us through how to find the surface area of a cylinder. Now, another way we can call a cylinder is kind of like a circular prism. Remember that prisms have two parallel congruent ends, and in a cylinder, our parallel congruent ends happen to be circles. And whenever we're dealing with circles, we have some different stuff going on. We have to use pi, and we'll see that throughout these examples. And the other thing we learned about prisms is that if we were to cut a prism anywhere in it, it maintains that shape throughout. So if I was to cut this prism in half, this cylinder, I basically am left with two cylinders. That's how we know it's a prism as opposed to a pyramid or a cone. Now, in order to do that, like I said, we have to talk about how to find area of circles. So we're going to work through some examples here, and we're going to find out how to find the area of a circle, which we've done in some other assignments, but also we're going to be looking at composite shapes, like this first shape here. Kind of looks like a racetrack, although the units are in centimeters, so it's kind of small, and it's saying find the area of this figure. So we have to look at this figure and say, what is it actually made up of? Well, if I was to look at this shape, really, I have one rectangle in the middle, that rectangle being 112.6 centimeters by 58.4 centimeters. And then I have two half circles on either end, but if I was to push them together, I actually have one circle that has a diameter of 58.4 centimeters. So if we could find the area of these two different shapes and add them up, we have the area of this solid, or sorry, this two-dimensional shape. So if we do the area of a rectangle first, remember, that's length times width. So we have the 112.6 times the 58.4. This will tell me how many square units can go inside that shape. And if we calculate this number, it's 6,575.8 square centimeters. So that just takes care of all of this stuff in the middle. Now we got to look at the circle. And a circle has a formula that's take pi and multiply it by the radius squared. And we're going to look about different ways we can do that in our calculator. But the big thing we need to know is we need the radius of this circle. And the diagram gives us its diameter. So in order to find the radius, I just take this and divide it into 2. The radius is half of the diameter. So the radius of this shape would be 29.2 centimeters. I just took 58.4 and divided it by 2. Now that's what goes into our formula here. So we have pi times the radius squared. Now, many calculators have a squared button, and if yours you can't see it or you don't know how to use it, another way is to say, well, this just means times it by 29.2 twice. So we'll look on the calculator here how we can put it in. If you have a pi button, we're going to say pi times the radius. And I have a squared button, so I can say pi times the radius squared, and I get this. Or you could use pi times, as we said, 29.2 times 29.2, and we'll get the same answer of 2678.6. So we'll say the area is 2678.6 square centimeters. Now the area of this shape then, the total area, is just adding up these two. So there's the rectangle, add up that complete circle that we pushed together, and we get a total area on this shape of 9,254.4 square centimeters. So we found the two separate shapes and then added them together. The next example is quite similar. It's actually just half of that racetrack looking shape we just did. And if I look, I can cut this into two shapes. I have a rectangle that's 3.5 by 3.25 feet. And then I have a semicircle, which is half of a circle, and it's 3.5 feet for a diameter. So we'll look at how we can find these two areas again, and we'll just simply add them up. So there's another length times width for a rectangle, which is 3.25 times 3.5. And the area of this rectangle then would be 11.38 square, oh, sorry, not centimeters, it's square feet in this example. So that would be the area of just the rectangle. Now this is a circle, so we know that the area of a circle is pi r squared, but this is only half of a circle, so we're going to end up dividing this by 2. So again, we could say pi times, oh, we need the radius. 3.5 is our diameter, so if I was to divide that by 2, the radius is 1.75. So 1.75 squared divided by 2. And again, I'll show you how this looks when we go into our calculator. So our calculator, we're going to say the pi button times 1.75, and I'm using my squared button, and dividing by 2. And again, you can go 1.75 times 1.75 divided by 2. So the area of this semicircle is 4.81 square feet. So the area of the combined two pieces, we take the rectangle, we add the semicircle, and we get a total area of 16.19 square feet. So these shapes that we just did are all building on one shape, adding to it another shape. This next one that we're looking at is a little different. We have a solid rectangle, and we have this chunk taken out of it in the top, which is a semicircle. So we're going to treat this a different way. We're going to say, well, if I had this whole rectangle, which is 250 by 310, if I could find that area and then subtract out this semicircle that's 90 millimeters across, which we should already start to figure out we need half of that distance, which is 45 millimeters. If I could find these two and subtract them, I would have the area of that shape. So the rectangle again, length times width, 250 times 310, which gets us an area of 77,500 square millimeters. Now if I'm looking at the semicircle, again, we just did this on the last example, it's pi times the radius squared. But we're going to divide it by 2 because there's only half a circle. So we'll say pi times the radius, which we said was 45 squared, divided by 2. And so the area, and if we put that in our calculator and did the calculations, we get 3,180.9 square centimeters. But now, like we said in the beginning, this isn't a situation where we're adding these two areas because we actually have a bite taken out of this rectangle. So our area in this case is subtracting the two areas. So there it is, as if there's no bite, the 77,500, subtract the 3,180.9, and that would give us a total area of 74,319.1 square millimeters. Now that may seem like a large number, but a square millimeter is really, really small. Now we're going to take this, we've worked with some areas of circles, and we're going to move and talk about how we can find the surface area of a cylinder. Now, we already looked at what a cylinder is, and here it is. And this right here is the net of a cylinder. So if I was to rip it apart, this is what a cylinder would look like laid out flat. We could see that the cylinder has two circles, and it has this rectangle that forms the lateral area of the rectangle of the cylinder. So we talked about lateral area being the stuff around the inside, not including the ends. So there's a formula for surface area of cylinders, and it's 2 pi r squared plus 2 pi r h. Now this is going to be important for this course. And just to break apart what we're actually talking about, this 2 pi r squared, the pi r squared you should see is the formula for area of a circle. So this is the two circles. And this is just the lateral area. So sometimes we're going to have to play with this formula and change some stuff around in order to find the surface area of what the question's asking. If the question says that you only need to find the area of the lateral part of the cylinder and one end, this just simply becomes pi r squared. We no longer need two circles, we just need one circle. If the question goes and says, all I need to know is how much material goes on the lateral area of this, the whole 2 pi r squared comes right off because we don't need to talk about the ends of it at all. So we really have to read our questions and determine what they're actually asking for. So we'll go down here and we'll take a look at what's going on in this cylinder. So let's find the surface area of a cylinder that has a radius of 90 millimeters and a height of 300 millimeters. So it's surface area. It's not saying forget the top or bottom. It's not saying anything just about the lateral area. It's saying the surface area of the whole shape. So we're going to use this entire formula. So 2 pi r squared plus 2 pi r h. Nice thing in this question, it does give us our radius. So we don't have to divide anything by 2. So the surface area then, 2 pi r squared, and my r is the 90 millimeters. So this would tell us the area of the top and bottom circle, plus 2 pi radius again, which is 90, times the height, which it says is 300 millimeters. This second part after the addition sign will tell us the lateral area, just that stuff around the middle. So when we calculate these numbers, you could do them separately and add them up. You could do it all in one chunk in your calculator. I'm just going to break it down so we can look what it looks like separately and add it up. And we can look in the next example how we can do it in one step. So I'll just do the 2 times pi times the radius squared. So this first bit would give us 50,893.8 square millimeters plus, now I'll look at the other part, 2 pi times the radius, which is 90, times the height, which is 300, that's the 2 pi RH, and that gives me 169,646.0. So the combined surface area of this cylinder, so the stuff around the outside, so the lateral area, and the two circles, we just take these two numbers and we add them up. So I get 16,946.0 plus the 50,893.8. And my final answer is 220,539.8 square millimeters. So that's the area of the top and bottom and the stuff all around the edges. We're going to create our own example at the bottom of this page that kind of manipulates that formula. So let's pretend that we have a cylindrical garbage can. Okay, and we'll say that the garbage can has a diameter across the top of 2 feet, and the garbage can is 2.5 feet tall. Now garbage cans means that the inside of this is hollow, so there is no top on it. So if I was to say, how much material did it take to make this? I'm talking about the surface area of plastic or metal or whatever this is made out of. So if my formula for surface area of a cylinder is 2 pi r squared plus 2 pi r h, if I was saying, okay, this garbage can doesn't have a top, it's just hollow, I just need to get rid of this 2 in front of this, because now I only have one circle, which is the bottom of the garbage can to look at. So then I can just do everything I need in my formula, except when I see the radius of this shape, it told me the diameter is 2 feet, so the radius must be 1 foot. So we're going to use that information. So pi times the radius, which is 1 foot squared, plus 2 times pi times the radius, which is 1, times the height of this garbage can, which is 2.5. And I did mention in the last question that we'll look at how we can do this in our calculator in just one step. So I'll clear my calculator, And I'll show you that I can just say, well, there's pi times the radius squared, and we're only doing one of them because we only need the bottom of the garbage can, plus 2 times pi times the radius times the height of the garbage can. So now my calculator, if I have a scientific or a graphing calculator, can do this in one step. I hit enter. The surface area of this is roughly 18.8 square feet. Now remember, we're saying we don't have a top on this garbage can. It's just open, there's a bottom, and the lateral area around the outside. So this talks about the lateral area, and this talks just about the bottom, because in this example, we're not putting a top on our garbage can. So you always have to read the question and see what the question's asking you to find.